Assalamu alaikum. Dear students, welcome. Let's start our discuss about the case studies that we have shared online. So first of all, we will talk about the first case study in which water enters at 2 cubic meter tank at a rate of 6 kilogram per second, and it is withdrawn at the rate of 2 kilogram per second. The tank is initially full. So let's talk about this solution. So first of all, we have to discuss about we have to imagine what is the question is and how we are going to solve it. So let's consider this is a tank which is its capacity is 2 cubic meter and it's half filled. So that means 1 cubic meter of the tank is half filled and one is empty. 1 cubic meter is empty. So in the next part, this water is entering at 6 kilogram per second in the tank, and at the same time is some part of the water is leaving at 2 kilogram per second. So that means this is the how we are going to make a draw of this diagram of this lecture. So first question is, what is the process type? So what we have to think is how we are going to identify the process type. We have studied 3 process types. One is batch, second is continuous process, and third one is the semi-batch process. As we all know the properties of these 3 types of processes, so we have to identify from the given data what is the process type. So if we think and focus on the things that we came to know that is involved the rate. So 6 kilogram per second and 2 kilogram per second. So when rate is involved, you can imagine and rethink that it's a continuous process, because its rate is only involved in continuous process. So that's why we call it as a continuous process. And then what is the state? State of this continuous process. As you know, we have 2 states. One is transient state and the second one is a steady state. So it is a transient state because the input is not equal to output. So we will call it a transient state of this process. So if we wrap up, the process is continuous and it is in a transient state. The second part of this case study is about the mass balance. So if you recall the mass balance equation, overall mass balance is equal to input plus generation, that is equal to output plus consumption. It's because we already discussed that all the processes in the food industry will follow the first law of thermodynamics, which states that mass cannot be created nor destroyed except the nuclear reactions. So as there is no nuclear and chemical reactions involved in food processing, so in this process also, so we'll call it that it's a very simple process. In other words, we can say accumulation is equal to input plus generation minus output minus consumption. As I already told you that there is no chemical reaction involved in this process, so we can say easily that generation and consumption in this process is 0 and that can be omitted, because there is nothing going to generate and nothing going to consume in the process, so both generation will be 0. Then our final equation, that equation about the accumulation, will be equal to input minus output. So here, if we recall our data, so we know that input is equal to 6 kilogram per second and output is equal to 2 kilogram per second. So if we solve it, then the 6 minus 2 will be equal to 4 kilogram per second. So finally we have the accumulation is 4 kilogram per second, which indicate that the water is at the rate of 4 kilogram per second is accumulating inside the tank. So at this rate, after some time, this water tank will be filled. So the process will become will transfer from transient to steady state. But that's this is all about the mass balance equation. In the third part, the question is at which time, how much time it will take to fill up. So if we talk about our tank, so its capacity is 2 cubic meter, but is half filled, so that means half or 1 cubic meter is empty. So our accumulation is 4 kilogram per second, so that means is in kilogram, while the capacity of the tank is in cubic meter. So we have to convert that cubic meter into kilogram, or kilogram back to cubic meter. So as it's easier to convert cubic meter into kilogram, so we'll use the equation that 1 cubic meter is equal to 1000 liter. That's the conversion factor, and 1 liter is equal to 1 kilogram. So then 1000 liter will be equal to 1000 kilogram. As the density of water is equal, we call it 1000 kilogram per cubic meter, so that we can say 1 cubic meter will be equal to the 1000 kilogram. So now we have find out that by doing this calculation, simple calculation, we came to know that we have to fill 1000 kilogram of the tank when the water is accumulated at the rate of 4 kilogram per second. So here, if we recall that now we can easily calculate that the 1000 will be divided by 4, and the resulting amount will be 250 seconds. So that means the 1 cubic meter of the leftover tank or unfilled tank or empty tank will be filled into 50 seconds. So afterwards you can easily calculate or convert the second into minutes and minutes into hours, depending upon the question. So as we only talk about the time, so second is the basic unit of the time. So we have came to conclusion that 250 seconds will be needed to half fill the tank. So this is all about our first case of study. So if you have a question, you can ask, and thank you very much.